Hello everyone, this is Mrs. Emanuel coming to you with solving multi-step equation. Guys, we got to get it together so we can perform in excellent. So the first thing I want to review is what is an equation? An equation, and I would be doing it, I would be showing a lot of notes and making complete sentence. So here we go. An equation is a mathematical statement. It's a mathematical statement that two expressions are equivalent, or you could say equal, and that's what I probably say, equivalent, okay? So that's that. I want to make sure we understand what an equation is. So what is a multi-step equation? That's going to be a lot of different steps to solve it. It's still an equation, okay? So, and the solution is going to be, in this case, it's going to be finite. It's just going to be one solution. So first of all, let me just go over a two-step equation per se, just a little. I'm not going to do a lot of it. So I'm just say solve the following equation. And I'm doing this to make sure you're right. I'm trying to model, if you will. So here we go. Let's start off with -6 equals k. K being the variable that we'll be solving for -6. Okay? This right here, if you look at this, you'll be like, well, actually, this is not even a two-step equation. You're probably saying this is just one step. And that's, you need to identify that. And you'll be like, how do you know if it's one step, two-step, or multi-step? Well, here we go. Look at the details. We have one variable, one operation on the same side with the variable, and we have a constant here at the left. So in order to get k, to isolate k, if you will, in order to isolate k, all we have to do is do the inverse operation to -6 or -6. So that means to undo -6, I would add 6 to both sides. Okay, and notice, for some of you, you may want to pause the video because of some things I'm saying. I'm not writing it. I'm not going to write everything. So I'm going to add 6 to both sides to isolate the variable k. -6 and a +6, they're at its inverse, meaning their sum is 0. That leaves me with k on the right-hand side. And -6 and +6, again, those at its inverse, so that will be 0. Okay? You probably say, what did you do? What did you do? I add 6 to both sides, and then I simplify. And I'm going to say simplify. Okay? Always check your answer. Okay? So if I put 0 in place of k, substitute 0 in for k, I would say 0 - 6. What is 0 - 6? -6. My solution is correct. Okay? So this solve the following what kind of equation? One step. So I'm going to put here, and I will, I'm going to put here one step. And now notice I'm just writing this over here. That was one step. So just trying to, you make your notes for yourself. Okay. So here we go. Let's do another equation. So we've done a one-step equation. Let's see if we could do something a little more challenged than a one-step equation. Okay? Or is this going to be a one-step equation? Let's do -4. Oh, solve. Okay, here we solve the following equation, one-step equation. Okay, so here I'm going to say solve. I'm going to just say solve, okay? I don't want to get stuck on writing down questions right now. So here we go. We have -4 plus 7x equals 3. Look at the details. That's what you want to do. You want to say, okay, on the right-hand side, I have a 3. I just have a constant by itself. It's alone. Here on the left-hand side, I have a -4 and I have a 7x. and ask yourself, what is happening to the x? What is happening to the x? And I'll write this question over here so you can, what is happening to x? If you know what happens to x, you will know what to undo. Okay, so here we would say x is being multiplied. X is being multiplied by 7. That's one thing. After x is being multiplied by 7, then what happens? Okay. Then you want to say x is being multiplied by 7, then -4 is added. Okay. So we have that there. So how do you undo this? How do you solve this equation? How do you solve this equation? And when I say this, I'm referring to -4 plus 7x equals 3. How do you solve this equation? This is the -4x. Let me put this equation. Okay, that's what that is referring to. So here we go. We have here, how do you solve it? If x is being multiplied by 7, then -4 is added. So how do I solve it? I will add 4. Add 4. You will simplify. Then you would divide by, because notice I'm doing the inverse operations. I would divide by what? 7. Okay. Add 4. Add 4 where? That's what you should be asking yourself. Where am I going to add 4? And you're going to add 4 to both sides of the equation. Okay. Simplify what? Do what you're adding, you're subtracting, what have you. Then after you do that, you're going to divide what? By 7. Both sides. Okay. So let's do it. So first you notice that we looked at the details of what was happening to the x. Then we asked the question, how do we solve this equation? And we did the inverse of what was being done to x. You do that all the time when you're solving equations. Okay. And so this is going to be a 2-step because we're doing 2 different operations. So here we go. Let's solve. We have -4 plus 7x equals 3. Following my steps. Add 4 to both sides. I'm going to add 4 to the right side. Here, 7x, I cannot add 4 there because the 4 doesn't have an x, so they're not like terms. Therefore, now I'm going to add the 4 to the constant because they are like terms. So here, -4 plus 4 is 0. That leaves me with 7x on the lovely left-hand side equals 3 plus 4 is 7. Then I add it and I simplify. Because when I counted and I brought down everything, that's simplified. Now I'm going to divide both sides by 7. Divide by 7, divide by 7. 7 divided by 7 is 1, so that canceled, leaving me with x. 7 divided by 7, and now my last step is simplify. You divide and you simplify. Okay? So therefore, I have here x equals 7 divided by 7 is 1. Okay? So I just follow the steps. Substitute the 7 in to check your solution. You do 7 times 7, you get 49. You guys see what I did? You notice? 7 times 7, 49. How are you going to do 49 plus -4 to get 3? Then you go back and say, ooh, she didn't get it. Yeah. Here, you see, and these are simple mistakes that you normally make. So you check yourself, then you realize, oops, dang, 7 divided by 7 is not 7. 7 divided by 7 is 1. So make sure you write what you say. Okay? Control your brain. Look, you see, you check yourself, and you be like, okay, this is 1. So now I'll go back, and let's try it again. And we say 7 times 1 is 7. Now that's more reasonable. Now I can see a 7 and a -4 getting a 3. But a 49, that wasn't reasonable. So 7 times 1 is 7. Negative 4 plus 7 is 3. And notice when I check, I use PEMDAS. Okay? Very good. So we just did 2 steps. We did 1 step, 2 step. Now multi-step is going to be more than 2 steps. Okay? So let's try a multi-step equation. And I'm going to you could just make sure you can pause the video and all of that. Make sure you do that if you need to. Pause the video and all of that sweet stuff so that you can make certain that you get what you need from this video. Okay. So it's going to continue. Let me move this to the side. Let's continue. I'm not going to put the topic on the top of the paper because of that's taking up time. So here we go. So, is this a multi-step equation? Okay. Let's write that. Is this equation, let me write it down, 2a plus 3 minus 8 equals 8, a multi-step. Is it a multi-step? Okay. So here we go. Let's do this. So you're probably saying, how do you know? Let's write it down and see. 2a plus 3 minus 8 equals 8. Let's see if this is a multi-step equation. So let's see. Here, I got an 8 by itself. We're looking at the details. Here I got 2a and I got a negative 8a. So if I have to combine those, that's going to be more than 2 steps. So yes, it's a multi-step equation. So yes, to answer this question, yes. And the reason is what I just told you. Okay, so I'm not writing it down. You could write down what I said, but just remember that. So here we go. Yes, so let's solve it. Let's solve 2a plus 3 minus 8a equals 8. When you have a multi-step, you're trying to consolidate your equation so it could be a 2-step equation. Okay, and then you're consolidate 2-step to be a 1-step equation. That's the goal. Okay, so here we go. We have here 2a and a negative 8a. Those are like terms. So I'm going to rearrange it using the community property. I'm going to say 2a minus 8a plus 3 equals 8. What did I just do? I used the community property. COMMUTATIVE. Okay. And that's okay. And I'll write it over here for you. I'll write it here just this well for you so you can see it. I'll write it under here to make sure I just used the community property. Okay. And the community property allow you to rearrange so your like terms can be together. Okay, so that's the first thing I did. I identified, well, there are extra move things around, but the first thing I actually did, I identified my like terms. Do that. After I identify my like terms, then I rearrange the problem using community property. Note that when I moved the 8a, I moved the operation that was to the left of it because it's telling you minus 8. Okay, you probably say, it says subtract 3. No, it said add 3, then minus 8a. Okay, so we did the community property. Next, we're going to simplify it by combining like terms. So I'm going to say combine like terms. So 2a minus 8a. So you're combining it by performing the operation on the coefficient. So the coefficient is 2 and negative 8. So 2 and minus 8 gives me negative 6a plus 3 equals 8. I just brought down my other constants. Now, look, we're back at 2 steps. So you follow the same process that we did on the other example. So the 8, I'm saying 8, the 8 as an apple, what is being done to it? First, we're multiplying negative 6 by it. After we multiply the negative 6 and the a, we add 3. So what we're going to do to both sides, and put both sides of the equal sign. So we're going to subtract 3. Okay. Subtract 3 instead of spelling subtract. I'm just putting the sign there. So I'm subtract 3 from both sides. Then I'm going to simplify. So add it to inverses. Their opposite goes to 0. That brings the negative 6a down from the left side. Then 8 minus 3 gives me 5. Okay. Am I done? Absolutely not. Have I isolated the variable a? No, I haven't. So since I have not isolated the variable a, I have to say, okay, what is being done? It's being multiplied by negative 6. So I have to divide both sides by the coefficient negative 6. Okay? Divide by negative 6, not just 6. So divide both sides by negative 6. Negative 6. Okay? Negative 6 divided by negative 6 is a positive 1. Therefore, I'm left with positive 1a because I'm simplifying now. So a positive 1a, I don't write the a, I just write the, I don't write the 1, I just write a. So I'm left with equals, a equals. Here I got a 5 and a 6. Ignore I have the negative there. The 5 and the 6, ignore the negative right now. They have nothing in common but a 1. The GCF is a 1. So I'm going to leave it as a proper fraction. So I'm going to leave it as negative 5, 6. Note that I brought the negative from the denominator, because we're going to either have the negative sign here with the numerator or beside the division symbol. Okay. Again, substitute the negative 5, 6 back into the equation to make certain that your answer is correct. Okay. And it would be good. And you probably said, do I have to go back to the original? It's good to go back to the original. However, when I see this negative 6a and I notice that that coefficient of a is, I can cancel out with this denominator, I go there. I will go there because I'm for certain that I know how to do 2 minus 8. I know how to make a mistake there. Now, on the other hand, here it could be a mistake, but with my adding and subtracting of integers, I should be really confident in that. Okay, that was one multi-step equation. Let's solve another one. Okay, solve the multi-step equation. Here we go. Let's do it with grouping symbols. Negative 2 times 3 minus d equals 4. Okay. Some of you may say this is not really multi-step. That's a 2-step equation. I can agree with you. I can agree if you say it's multi-step. I can agree if you say it's 2-step. Okay. Since we're practicing multi-step, I'm going to focus on multi-step. Okay. So when you see grouping symbols and you're solving for a variable, you're solving an equation, get rid of the grouping symbol. In this case, this is not the only way, but I'm going to make it multi-step instead of 2-step. So what I'm going to do first is get rid of the grouping symbol so I can get into to see what is really going on with the D. Okay. So I'm going to do the first thing, distributed property. Oh, sorry guys. I know that's taking up time, but I'm going to perform the distributed property. Okay, distributed property, that's what I'm applying here. Oh, me and my handwriting. Take the negative 2 and distribute to every term within the grouping symbol. So I'm going to say negative 2 times 3. I'm showing every step. Okay. Then I have negative 2 times negative d. Negative times negative. Babies, I'm going to get rid of that now. Negative times negative, I know is a positive. So I'm just go ahead and put positive. 2 times d equals 4. Okay. Then I'm going to simplify by multiplying. Okay. The 2's. So I got negative 2 times 3. They give me a negative 6. Plus 2 times d is just 2d equals 4. Then you'd be like, oh, we're back at 2 steps. Absolutely, you're back at 2 steps. Then you say, what is being done to the D? It's being multiplied by a positive 2. After that, what's being done? We're adding a negative 6. So now you know that you're going to add a positive 6 and divide by 2 because you're inversing it. You're using inverse operations. Okay? So here we go. And we're doing it to both sides. Both sides of the equal sign. Okay? So I'm going to add 6. Then I'm going to simplify. Then I'm going to divide by 2. Divide by 2. Okay. Sorry, just put by 2 here. Then I'm going to simplify and you check. Okay. So here we go. So I'm writing, I wrote this here. If you can't read it, if you just slow the video down and listen to the words I'm saying, you will get it, okay? So add 6 to both sides of the equal sign. Remember, it's got to be like terms, so I'm not going to add the 6 with the 2D because I'm trying to get rid of the negative 6. So negative 6 plus 6 at its inverse is 0. Bring down my positive 2D because I'm simplifying now. 4 plus 6 is 10, okay? Now it says divide by 2. Then I'm going to simplify. Divide both sides by 2. That's the coefficient I'm trying to get rid of. That's attached to the D. 2 divided by 2 is 1. I'm simplifying now. 1D, I do not write the 1. However, I write the variable D. It's isolated. 10 divided by 2 is 5. No, I don't leave this as improper fraction. I have to make sure I simplify. Take the 5, substitute it back in to check, and follow PEMDAS. So I say 3 minus 5, 3 minus 5, negative 2. Good. So I got negative 2 times the negative 2 gives me a positive 4. I know my solution is correct. Okay. So here we go. Moving on. Let's do some more fancy problems. Let's do some more. Okay. Let's solve. And you're probably saying, why am I doing this? For Cornell Notes, so you can go back and write some excellent questions. You know, you can listen to what I'm saying and go back, okay, and write some excellent questions. And because I'm just writing solve right now. Trying to, okay. And remember, the video is sort of lengthy here. It's already 22 minutes and some seconds. However, remember, you can fast forward. You get it. You just go on, okay? You just go on and write the notes that you need, okay? Plus 2x equals 40. Okay. So here you'll be like, wow, we got group assembly. We got 2x over here and blah, 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 blah. So, okay, the first step, get rid of the grouping symbol. Use the distributor property. I'm not writing it down. I'm just saying it now. So I'm going to take the 4, distribute it to get rid of the grouping symbol. So I have here 4 times x, 4 times negative 2. So I'm going to just say minus 2 times 4. That's the same thing. Plus 2x equals 40. Okay. Next, I'm going to go ahead and simplify by multiplying. 4 times x is just 4x. Negative 2 times a positive 4 is just a negative 8 or subtract 8. Plus 2x equals 40. Okay. Am I done? Have I condensed it to look like a 2-step equation? You're right, I haven't. I have a term 4x. And I have another term, 2x. I have 2x terms. 2 of the x terms. Now I'm going to rewrite it to put my like terms beside each other. Use community property. I'm applying it. Have 4x plus 2x minus 8 equals 40. Okay. Next, I'm going to combine my like terms. And I get 4x plus 2x. That's 6x minus 8 equals 40. Woo woo! Where are we at? At 2 step. What's being done to the x? We're multiplying 6. Then we are subtracting 8. So what am I going to do? Add 8, divide by 6. Add 8 to both sides. Negative 8, positive 8. At its inverse goes to 0. That leaves me with 6x on the left-hand side. Combine 40 plus 8. I get 48. The next thing I'm going to do is divide both sides by 6. Because I'm trying to isolate the variable x. 6 divided by 6 is a positive 1. That leaves me with 1x. Do not write the 1. Just write the variable x. That's understood to be 1x. 48 divided by 6 is 8. Take your 8, check your problem, substitute back in. Okay? If I substitute back here, I say 8 minus 2. I get 6. 6 times 4 is 24. Then I have 2 times 8 is 16. 16 and 24, you put it together, you should get that lovely 40. Okay? Guys, it's been good. Have a wonderful time. Rewind it, pause it, do what you need to do. Make sure you understand, solve an equation. Love ya.